Hi everyone. Sorry for the delay. So yeah, I think we are good to start. Uh, so very excited to start LLD today with you guys. Before this, I have taught HLD to a few folks here. For those who guys have already studied HLD with me, can you please ping in the chat and let me know so that I have a good idea of the mix of the people here. So I'll start by introducing myself. Okay. So hi, I am Gaurav and I am a software engineer at Uber. And before this, I was with Microsoft and I have full stack experience on the entire JavaScript stack. I have also backend experience with Python and C Sharp and now with Go also. So in the last 1 year, I have cleared interviews for all major companies like Amazon, then there is Salesforce, of course, Uber and LinkedIn. So I have a fair idea of what people expect in the market right now. What are their interview processes, right? So this entire course will be focused on that. Okay. So this entire course will be focused on learning LLD from an interview perspective. Okay. The good thing about LLD is that it is also applicable to your day-to-day engineering. Okay. So this will not only just help you clear interviews, this will also help you become a better engineer. Because I assume most of you are at the SD1 level or early in your careers. At this level, learning LLD becomes super important so that we can contribute to design discussions in our day-to-day job. Same was the case for HLD, but that is more of a requirement when you are in your mid to experience mid to high experience level. So with that being said, so let's start with a basic question: what is LLD? So those of you guys who did HLD with me, you would remember that when we were designing high level systems, right? When we were doing high level design, we were asking questions like, how does the system scale? Where do I store this data? Right? How will the system perform under load? So this was the question that we were asking. We were not focusing on individual services. We are focusing on how these services will communicate each other. How will each of these services scale? How will they handle load? All of these questions what we are addressing in high level design. LLD is a different thing. In LLD, we focus on that services like in HLD, when we were talking about, we said that, okay, we'll create a user service. We'll create a notification service, right? And we don't go into the implementation details of how those individual services work in detail. LLD is where we dive into those individual services, right? We talk about how can we create a notification system. We talk about how we can create a simple, like today we'll do a tic-tac-toe LLD design, right? So we will talk about how can we can create a system in which someone can come and play tic-tac-toe in a single machine. Okay, we are not talking about how many people will come and what is the kind of throughput that we need to support. Those questions are out of the board. What we are focusing on is how do we design this tic-tac-toe system such that in future, if there are new requirements that come up, they can be handled easily. So that is what LLD is all about. So in a nutshell, here we will focus on classes, objects, inheritance, the design patterns. We'll learn what design patterns are, right? And following the solid principles. So this is LLD in a nutshell. Today's agenda is, of course, first topic we've already covered. What is LLD, right? We'll continue a little bit on more on it. Then, so since this class is like the first class, we'll start from the very basics. So today, we'll cover object-oriented programming and the core concepts that you need to know. Again, no one in an interview is going to ask you what is abstraction, what is polymorphism. No one is going to ask you theoretical questions. Maybe some companies might, but that's the case, right? No one is going to ask you theoretical questions. But these concepts are important for us to know in order to defend our design. When we design something, we should be able to defend it. Why we went ahead with this choice, right? So that's where basics of OOPS and solid principles and this dry and Yagami principle come into place. Okay. Then we'll go through UML. So UML stands for Unified Modeling Language, if I'm not wrong. The thing is that UML was very famous around 10, 11 years back, right? Nowadays, no one uses it. Okay. You will not use UML in your day-to-day life. You will not use UML in an interview. No one is going to force you to create a class diagram using UML. But again, it's a good to know thing, right? And it's just something that we should cover in just in case an interviewer asks us to draw some design complying with UML basics, right? So that's something we should know. So we'll cover that. Then we'll move on to the LLD delivery framework. Now, this is where, we switch our focus from learning theory to understanding how do we answer a question in an interview setting. Okay, so this is where I will define a framework for you guys to that so that you can take this framework, and whenever you encounter a new LLD problem, you can just follow this framework, and you can come up to a workable solution. This is something very similar to what we did in the HLD course, right? When we were discussing how do we design high level systems. So what we did was we defined a framework for us, and we followed that framework. And at the end, we had a design that met all the requirements of the interviewer. So that's what we are going to do with LLD as well. And then to wrap up today's class, we'll do a tic-tac-toe system design. Okay. So this is like most famous, most basic LLD problem that all of you would have already heard. And if some of you have already prepared for interviews, you would have already seen this problem. You have already solved for this problem. So this is something that we'll cover today. So before we start today's class, I want to set a few expectations straight from you guys. So I want in my classes, right? It's not going to be like that. I'll keep teaching. I'll give you stuff, like I'll keep talking, and there is no feedback from you guys. I would encourage you guys to raise your hands or write in the chat whenever you have any doubts. Whenever I'm asking any question to you guys, right? I would really appreciate if you could just ping in the chat or raise your hand to answer. Okay. And same goes with any doubts. So I will stop midway whenever I'll ask for doubts midway, right? If I am not stopping for a long time and you have a doubts, you can put it in the chat or you can raise your hands, but don't just, let it be. Okay. If I think the question is important enough, I will answer it right there. If not, then we'll take it towards the end of the class. Okay. Is that clear? Give me a reaction, or in the chat you can say yes. Awesome. So we already talked about what is LLD, right? Now let's talk about why LLD matters in an interview. Okay. So again, let's take a parallel with the high level design system interviews, right? High level system design interviews. There, what happens is that even if you don't know in detail how a particular component works, for example, if you don't know how Kafka internally works or how Cassandra internally works, you can just go draw these boxes and say, okay, I know that Kafka is good enough here. Kafka gives me these guarantees, and that's good enough, right? So you can fake a lot of stuff there, but LLDs are a little difficult to fake, okay? Because the core concept of LLD is I am giving you a system that I want to run. So your code should run for that. Okay. Some companies, they expect pseudocode, like, okay, the code, you don't have to write the exact code, but you have to write pseudocode. While some companies, they expect that you should write runnable code. For example, Uber expects that you write runnable code. Amazon has a very loose expectations where, they focus on pseudocode, and maybe sometimes they just want the class diagram also. It just depends on the interviewer. Okay. But yeah, their requirement there is not that hard. But with Uber, you have to write runnable code. That's the requirement, right? And the thing is that when you are trying to solve an LD problem, so either you have a clean class structure, either you have created the class perfectly, or in most cases you have not, right? In most cases, your designs are not extensible. You have to modify a lot of things in order to justify just a small new feature to be introduced. Okay, so these kind of things are a little difficult to fake in the interview. That's why the best way to learn LLD is to practice yourself, and that is what I will suggest you in this class as well. Okay, so as we go forward in these classes, you will see that we'll cover some theory part, and then we'll cover some questions, right? Some system designs that we'll cover in the live classes. So I want you guys to not just be present in the class for them. Once those systems are covered in the class, I would really appreciate if you go home, write the code out themselves for yourselves, right? In this class, I'll just show you. I will not write the code here because that will just take too long. Here, what I'll do, I'll walk you through the code. So I have the code written. Okay, I'll show you that code, how it is running, how it matches the class diagram that we just created, right? I'll show you all those, and then I'll share that code with you post the class as like in notes or some format, so that you can go through the code and do your own analysis. But before you go through the code that I send, I would really appreciate if you just try to code it out yourself, okay? Because you will have a class diagram of your own. You just go ahead, implement it in the language of your own choice. Okay, here we will be using Java in this class. Okay, as a language. If you're not comfortable with Java, if you want to try JavaScript or some other language, feel free to go at home and create your own set of like a repo in which you write all of these design patterns in those languages. But in this class, we'll be following Java, and if you have any doubts related to that, I'm here to answer. Okay. Now that's from the interview perspective. But in the beginning, I said that LLD also matters in real jobs, right? I have said that, and in the last class also, I said that like in the HLD class, I did mention that LLD is what as at the early to mid career level, LLD is what you do in a daily basis. You're not designing new systems, I know, on a daily basis, but LLD is something that every time you write a code, you are following some design pattern, or if you can come up with some design pattern to organize your code better, that helps, right? Even a lot of you guys would have observed, like all of you guys are working professionals, all of you guys would have observed that teams burn through around 4 to 5 months just because of LLD debt, right? They did not write the system in an extensible manner. Now whenever a new request comes in, just integrating that new request takes so much effort that people just skip it. They says tickets remain open, and a lot of friction is created just because if you want to implement a new feature, it's just going to take too long, right? Like for example, let's say there is a user service that does authentication, that has database access to it, that can send emails, that can do analytics, anything. And let's say some other day we have to change the email logic. Now, because everything was in the same service, we risk breaking authentication, right? So all that kind of stuff you guys would have observed in your daily work as well. So if you have gone through these problems, uh, give me yes in the chat, or a react, whatever you feel good is. Okay, right. See, already a lot of people have gone through this problem. So in this class, we will focus on fixing that. Okay, we'll focus on how do we build a mental model in a way such that we can design code in a way that we don't have to go through a lot of iterations in order to make it perfect. Okay, so that's that. So one thing that we'll do, we will design for change. Okay, we will design in a way that in future, if some change is needed, it's easy to do, and will not design for perfection. They are not in any interview, in any LLD or HLD interview. The interviewer is not looking for a perfect design, right? He has some things in his mind, but he is not hell bent on it. Okay, so if you can put like all of these run on trade-offs. So if you can identify the trade-offs and speak them freely, that works, right? So that's what we will focus on. We should be owning our decisions. That is the core thing. Okay, if we are deciding to use some design pattern, if we are designing to use some inheritance or something like that, we should own that decision. We should be able to back it. So that's the thing that you guys should focus on. So with that, let's start with our first topic of the class, that is basics of hooks. So a lot of you would already know what a class is. So if you can write in the chat, or unmute yourself, raise your hand. I'll ask you to unmute, and then tell me what is a class. Yeah, Deepak, you can go ahead.
A class is a blueprint that what we want to build.
Exactly. So what is a class? Class is basically a blueprint of some real world thing that you want to represent in code, right? So it is not the actual thing. For example, let's say we are talking about a bank account, right? A bank account is some real world entity that you want to represent in code. It has some data, it has some methods, right? It has some actions that we can perform on top of it. So a class lets us define all of that in one shared blueprint. Okay. So let's say if I'm trying to write a bank account class, so this is something that I will write. Uh, so this is how a bank account class will look like in Java. So we define public. This is the access modifier. We say class. This is the Java keyword, right? And then we give the class name. I'll tell what access modifiers are in just a second. Okay. And then we have bank account, which is the class name. And this class now has a few data objects. For example, we have balance, we have account number, and then we have owner, right? And they have their own data types. And then there are some methods that we can perform on top of it, right? These are like the behavior. like some actions that we can perform on this bank account. For example, we can deposit some money in this bank account, we can withdraw. So this blueprint is called a class. So here, this bank account is a class. Okay. Now let's talk about these access modifiers. This is basically who can access this class, right? Public means in your code base, any class, any module, anyone can access this bank account without any problem. Okay. Then in this fields you will see private, right? Private means that no one outside this class can directly access balance. Okay, so you cannot. We will just see how what I mean by that. But let's say you create a new object, right? So you cannot directly modify this. You cannot directly access this balance. Okay, you cannot access account number, and this is important because right, if anyone can access this, then it will be a problem, right? If anyone can access account number and change it, then this classes or this object's data sanity is not ensured. So all changes must go through these functions. Okay. So this is what a private is, and like as Deepak is saying, for a friend class, that is basically subclasses. That protected is the keyword for that. Okay. So yeah, so that's pretty simple. Class is just basically a blueprint. Okay. Now let's talk about what is an object. Yeah, again, because this is a very basic thing, so that's why I'm asking you guys to explain what is an object.
Instance of a class.
Exactly. It's a concrete instance of a class. So if we continue with the bank account example, right, we can create, we like this is the object is basically in memory. It represents the actual, this is like the actual object that will contain the data fields that we described as a part of this class. Okay. So if you look like this is the thing that exists in the memory, right, and can be accessed, modified, and all of that stuff, right? So if you want to create a new object in class, you can in Java, you can simply say bank account ls account is equals to new uh, new bank account. Okay, so there's that. This is pretty simple. Now tell me what this new keyword does. Yeah, Deepak, go ahead.
It creates a memory on a heap.
Exactly. So basically what this new keyword does is it creates this object using this constructor. We'll cover what a constructor is. Okay. So it creates this object and assigns it to ls account. So now you can do stuff like ls account dot deposit 100, right? So you can now call these functions on top of ls account in order to modify the data that this account has. Okay. But can you do ls account dot balance minus equals to 100? Can we do that?
No.
Exactly. We cannot do it. Why we cannot do it?
It's a private one.
Exactly, because this is a private thing. Okay. So objects, classes are clear, objects are clear, methods are clear, access modifiers are clear. If you have any doubt till now, let me know in the chat. Otherwise, we'll move on.
I had just one question.
Yeah.
So probably you would explain this in future, but just wanted to know, like, in like compiled runtime overloading. So
Yeah, we'll come to that later.
Sure, okay.
Yeah.
And every language handles in a different way, right? So in C++ has vtables, and then I don't know about Java. It has
Yeah, C++ has virtual pointers, but we'll not go into the deep detail of how each language implements it. We'll just see what it is and why is it important for object-oriented programming.
sure. Thank you.
Okay, so that's the very basic done. Now let's talk about static and instance members. Do you guys know what static members are? Yeah. If someone would like to explain it to the class.
It cannot change the instance of the starting user.
Arpan, your audio is not clear. Maybe you can write in the chat. Or if someone else wants to go.
Instance members are a part of the class, and like it is associated with the class. Static is, even though you write it within a class, you can like you basically it's not an identity of the class.
Actually,
Talking
that
in
is
terms of Python, I don't
uh,
know. how-
oh, no, no. So static and instance in general object-oriented programming terms or in any general language terms, static means a variable that belongs to the class. It means that when you create a new object, right? When you create a new object, all of these fields that you defined here, these get created, right? These are fresh fields that created for a new object, right? Every time you create a new object, these fields are freshly created. So these are called instance fields. But a static field, when you define via a keyword called static, when you define it like that, that field now belongs to the class, right? So even though you can modify it via using object dot, but it if you modify it, it will get updated for all the objects. Okay, it will not reflect only for that object. It basically belongs to that class as a whole. Okay, so any changes to it reflects into all the objects, and it is owned by, like, the real ownership is with the class, and that's why you should not, for static objects, you should not do object dot and then modify them. So I'll explain this with an example. Okay, so again, continuing with the bank account example. So this is the class that we were talking about, public class bank account. In this, we have added this new field called let's remove private from here. Okay, for now let's just call it static int total accounts is equals to 0. Now, since this is static, this will be shared across all the objects. Okay, it will be shared across all the objects. Or you can, okay, you can call it private because we are increasing this in the bank account. So yeah, so in the constructor we are increasing it. So that's totally fine. Okay. So now if I do this, just let me copy this. Okay. Now if I do this, okay, tell me what will be the value of Alice account dot total accounts. Also, let me just do this. This dot balance is equals to 0. Okay. So yeah. So what will be the value of Alice account dot total accounts, and what will be the value of Alice account dot balance? What will be the value of these two?
1 and 0.
Which shall belong.
Yeah. So this will be 1, of course, right? Because we did total accounts plus plus here. That's obvious. And balance will be 0 because we assigned the balance to 0, right? So let's do that. And now, okay. So let's do one thing here. Instead of, so let's modify this constructor first. Let's call it, we are getting an int x, right? And we say x here. And we do 100. So what will be the value of ls account dot balance here? 100, right? Correct, 100. And what if I now create another bank account? Okay, let's call this Bob account, and I assign it 500. Then what will be the value of a Alice account dot total accounts? Okay, then Bob accounts dot total accounts. Okay, then again Alice account dot balance and Bob account dot balance. What will be the value of these 4 fields?
Alice account dot total accounts will be 2.
Will be 2.
Yeah.
Okay,
Bob account dot total accounts will be 2.
awesome.
Alice account dot balance will be 100. Bob
Right.
account dot balance will be 500.
Exactly. Now you see, because this is a total accounts field, is a static field, it is shared across all the objects, right? It is shared across all the objects. So when we create a new bank account, we increase the value of this total accounts by 1, it becomes 2. So it is updated for all the objects, because basically objects don't have it, right? It is with the class. So they are just referring it via the class. So it changed for the class, so it changed for every object. but this balance field belongs to the objects. This is an instance field, right? So this belongs to the object, and because it belongs to the object, it remains decoupled. It remains independent for each object. So that's why ls account.balance remains unchanged even after creating a new object. So any doubts in static versus instance variables? You can in fact access, this is one thing, good thing about static variables is you can also access them via the class name. So you can just say bank account dot total accounts, and even this is just fine. Okay, cool. So yeah, with this done, let's talk about constructors. Can someone tell me what, like I did give you a slide demo of what a constructor is, but can someone tell me what is a constructor? Yeah, Deepak, go ahead.
It's a function when it's run when the object is created, it runs a constructor.
Object is created, it runs the constructor. Can you put it in a better framing? See, because like in an interview, I'll suggest when you speak something, you should be very clear with what you mean. Okay, so always try to answer in that manner.
So it's a first function ran when the object is constructed.
Again, the object creation is a side effect of the constructor and not vice versa. So a constructor is a method that has the same name as the class, and it is used to create a new object. Okay, it's not the other way around, that when objects are created, constructor is called. It's the when constructor is called, the whole purpose is to create a new object. Okay.
Yeah, got it.
Yeah. So that's pretty simple. So again, taking the same example of bank account, I'll write a constructor here. Okay. So in this bank account, we define two fields. One is balance, one is owner. And then we accept these two fields in the constructor. So you can use constructor to accept a few parameters from the caller and assign it to the class variables. Okay. So we got these two fields, owner and deposit. And now we assign this dot owner is equals to owner, and this dot balance is equals to initial deposit. So can you tell me what does this mean here, and why do we use it?
This refers to current object.
Okay. Yeah. So that's the short answer, that this refers to the current object. Now I want you to but I'll explain it to you guys like in a detailed manner. So now imagine when you are writing this constructor, right? You are writing this constructor as part of this class, correct? So if you just say owner is equals to owner, what does this mean? This does not mean anything, right? Because this class cannot hold objects. It cannot hold value of fields, right? It cannot. So what we do, we are this basically this is inside a constructor, and inside this constructor, what we are trying to say that I want to create a new object. So that new object is created in a memory, right? And we are trying to refer that memory via this. Okay, so we are just saying whatever new object you are creating, or whatever object is calling this method, right? This refers to that. Okay, so if you are doing, let's say, again, if you're trying to create a new account, okay, if you're trying to create a new account, bank account, Bob account is equals to new bank account. So when this bank account is executed, at this point, that this refers to Bob account. Okay, and if you are trying to create another account like this, okay, when this line is executed, then this refers to ls account, right? And if you write a new method here, okay, let's say you write a new method, public deposit, it takes a integer x, right? It takes an integer x, and you just simply say this dot balance plus equals to x. You just simply say this, right? So when you call Bob account dot deposit, right, 100. So when you call this, at this point, who is calling this deposit? Bob account, right? So this refers to the Bob account in this case, right? And if I say Alice account dot deposit 1,000, so when this is executing, what does this refer to when we are trying to say Alice account dot deposit 1,000? And I don't think it's very clear to people what this means. This is pretty simple. Like, okay, I'll give you guys a chance to ask you questions, and then I'll rephrase it, seeing what is it that you're not understanding, and then I'll rephrase. So ask the questions if you have any. Deepak has raised their hand.
Yeah. So, but not about this, but about the constructor part.
Yeah.
So I had some spaces in my thought process. Like by default, we have a default constructor, right?
Right.
And we can assume that default constructor has some code which can create memory location. But
Correct.
when we define a constructor, the default constructor is overridden. And how does the default constructor knows how to create a memory location? Is it like inheriting the default constructor by default, or is it a default code inserted into that constructor?
I think it is in the new keyword that there is, right? So you can give it to the language's internal implementation that like in Java, all constructors should have the same name as the class, right? So whenever you write a method with the same name as the class name, the Java compiler knows that it is a constructor, right? And maybe then there is some internal implementation or some internal modification that it does in order to make sure that it creates a new memory location, right?
Also, just a follow-up question. Like, is these kind of questions encouraged? Like, are we going in this depth, or are we like just about code design and then all those things?
So language specific questions, I don't think this is a good place to ask because yeah, this will be a very design focused space, right? So we'll be discussing how different things connect with each other. But yeah, you can ask or you can even ask ChatGPT at this point. So it's totally fine. Like if I know, I'll answer. Otherwise, you can always ask ChatGPT. It's totally fine.
Sure.
Okay.
Thank you.
Yeah. Yeah. Tanisha, your hand raised. You can ask.
Yeah, so actually, I'm just doing an analogy between Java and Python. So
Mhm.
in Python, what happens is we have init, which is acts like a constructor.
Right.
But when you have like see in your constructor, you have written owner and initial deposit, but in your class variables, you have written balance and owner.
Right.
Okay, so when you're creating this instance, like when you're creating Bob account,
Right.
you are passing only one value like 500. So shouldn't we
Yeah,
be
this is
passing
just an example. So you can like it. You have to pass both. So
both,
you have
right?
to.
Now,
Yeah.
one more doubt I have is your class variables have balance and owner, and
Mhm.
your constructor has owner and initial deposit. So,
Yeah.
like, what is your like keys that I mean values that you'll be passing? Will it be owner and initial deposit or uh like balance or owner?
Yeah.
Like,
So please understand what is happening here. Okay, Python handles all of this very differently, like creating a new class
yeah.
and everything. In Java, what happens is think of this as an independent function. Okay,
Mm,
think of this as an independent function which takes two parameters, owner and deposit. Okay,
mm, mm,
initial deposit. When you pass these two, right, these two variables from here, this function starts to execute. Correct?
got it. Mm,
When this function starts to execute, here owner represents LS and initial deposit represents 500. Clear?
mm,
Now we are saying, now if I do owner is equals to owner, right? This will not do anything because
mm,
owner
got
is the parameter that we passed, right? So owner is equals to owner is 500 is equals to 500, which does not make any sense, correct?
mm,
That's why in order to like make it easier for us to understand and like ideally we can use balance also here, right? That's totally fine. But
mm,
in order for us to like because a lot of cases what will happen is that the parameters that you are accepting and the fields in the class will have the same name. So what we
okay.
do, we say this dot owner. So this again represents to what? This represents to this Bob account that has been created, correct?
Mm, mm,
Right? Sorry,
yeah.
this will be Bob. My bad. This will be Bob and this will be Alice, right? So yeah. So this represents to this Bob account. So we are saying Bob account dot owner. So when we
Mm,
say Bob account dot owner, what does it represent? It represents this, correct?
mm,
And we are saying this is equals to 500, right? Because owner
mm.
here was 500, right? So we are saying this equals to 500. So we have successfully initialized the value of owner for Bob account.
Okay. Okay. So my only question was like, even though like you have initial deposit as one of your parameters in your
Hmm?
constructor, that will not be like access, that cannot be accessed across the class, right? Because it becomes private
No.
to.
It is like, as I said, it is like an independent function. So the scope
Okay.
for this, all both of these parameters is between these brackets.
Okay, but owner and balance can be accessed throughout the
Right.
class.
And they can be accessed
Okay.
via this dot, right? So you
Okay.
can
Okay.
access them throughout the class, yes.
Okay. No, because in our in Python, it's like if you've defined anything in init, you can be able to access it across the entire class.
Yeah. Yeah, because
So
in
that's why I
Python
was
you don't
confused.
Yeah, because in Python you don't need to initialize, you don't need to define the variables like we did here, right? In Python you
Yeah.
have to define it. So in Python what happens is that whatever you define here and whatever you say here in the init function, it is available globally. But
Yeah.
in Java that is not the case. In Java you have to define the keys and like here you have to define the fields here.
Got it. Got it.
Yeah, right. So
Uh,
any
I
doubts
just
on this or any
just
other
had
thing?
one. I just have one suggestion.
Yeah.
So even I'm also not native to Java. I normally work in C++. So what I do is I like open new ChatGPT chat, and then I'll say I'm taking a LLD class in Python Java, and then this translates me into my own language. So that actually helps a little bit.
Yeah, I think that's also very good suggestion. Yeah. So any doubt on this, like this, the keyword and not the topic that we are discussing? If not, then we can go ahead. Give me a thumbs up. Awesome. Right. So now we'll move on to object-oriented programming. Okay. The four pillars, like this is the most famous thing. Like in every college, in every Viva, this is the question that is asked. What are the four pillars of object-oriented programming? So yeah, I'll give it to you guys. Tell me first of all the name, and then we'll go one by one and discuss them in detail. So just give me the four names of object-oriented programming.
Solid principles.
No, solid principles is not the like four pillars.
Polymorphism,
Inherited.
polymorphism,
Encapsulation.
inheritance, encapsulation.
Right. Sorry, you got
Override.
cut off in between. One of you, please, Tanisha, or like one person, please.
Polymorphism, inheritance, overriding, and encapsulation.
Overriding is not one.
Oh, okay.
Abstraction.
Abstraction.
Yeah. Awesome. So you guys all know the names at least, right? And now we'll discuss what each of these are in detail, right? And this is where we'll cover the overriding versus overloading wala cheez, right? That someone asked, I don't remember the name. Yeah. So we'll start with encapsulation. Can someone explain me what is encapsulation? Yeah, Shubham.
Basically, a class is a.
Yeah, it's like a capsule of class and object and their methods, getters and setters.
Yeah. Getters and setters. Okay. That is the correct explanation. It is
Hiding
basically
visibility of data.
that is one part of encapsulation, but yeah, that is correct. Hiding visibility of the data. So it's basically bundling the data and the operations that you can perform on that data into one single thing. And as a lot of you already said, a class basically, right? Basically, a class is a part of encapsulation where you take all the fields that belong together, right? You take all of them and you take all the actions that you can perform, all the methods, all the behaviors you can perform on that on those fields and put them together and use them as a bundle, right? Like for example, the bank account class that we use, right? It had fields like balance, name, on what else, right? A lot of other fields. That all belong to a bank account, and all the operations you can perform to the bank account are also bundled with that class. Okay. So yeah, Deepak, go ahead.
Sorry, I just have like lot more questions here. So I know the part of encapsulation why we use it, but I mean, I'm not sure about why we use it, but I know how to like use it and everything. But let us assume that we are writing all the code, and we have this bank account balance, which is to be like a very important thing, which is private, and then we have getters and setters. But why do we need it? Because since we are writing all the code, we can make sure that we are not, directly adding and manipulating. So even though if it is public, it's not like any other external program is accessing that variable. It's just the
Right.
internal program.
Right. So Deepak, I'll ask you a simple question. In whatever company you're working, is the entire code written by you for that company?
No.
No, right? There's a single code base in which many people come and contribute. Am I correct? That's just
Yeah.
one part of it. That's just one reason for it. You are it's not all you are not always going to own that code, right? Someday someone else will come and try to modify that code, correct? And they might not know what fields are supposed to be touched. Bank account balance is something that is very on the nose, right? We know that we have to keep it secure, but you let's say you're designing some other system, and in that there are some fields that you don't know, that like a common person would not know, that we don't touch this field outside the class, or otherwise it will pollute the state, right? So how do you do that, right?
In that case, I mean, inside they can write one more function inside the class which can do the same operation which they are doing outside.
Yeah. So now there
Um,
are two ways to do things, right? And still anyone can do the first part, right? Still there's no strong action against it, something preventing it. It will only be either in a code review or in production bug it will be identified. So that's why that's one thing. Secondly, think of companies that produce this code as a product, libraries, right? Think of libraries that exist, right? They, like, you basically are using someone else's code in your code and then doing something. So if they let you modify their internal state just by doing dot, then it's a problem for them also, right? They cannot predict the behavior again anymore. Understand?
I mean, when it comes to libraries, yeah, that makes sense. Yeah.
Right? So that again, there are a lot of examples. I was just giving you one by one. So that's why it's very important to just bundle all of this together, protect the fields that you want to protect, and then just don't let anyone handle it directly. Also, like, if you want to do it, you can do it, right? If you want to make a field accessible and editable by everyone, you can do it. You don't mark it private and anyone can do it. So that's your choice. But there are still strict use cases for this. Okay. So
Um, just a follow-up question. We know about all this, that one developer who, with, I think it's JQ or some other programming language, there's some other tool they exploited by being a contributor, and then they shipped a malicious code, like a Chinese hacker. So if that is the case, then even in a company, someone can do the same thing, even if it's public or private. So I don't think we are directly restricting someone to change the value. It's just, I'm not really, I know the concept, but I'm not really trying
yeah,
to place like how we can use it.
let me give you a simple example with this bank balance thing only. Okay, let's say you have created a library that you are giving to people. Okay, let's say you have implemented a simple library that lets people create bank accounts and set their balances. Okay, let's say you created this library. Now you did not mark the bank balances private. Okay, now someone is like in the someone is using a library, or someone hacked into the client that is using a library, and they added their code where they simply said that this dot balance is equals to minus 10,000. Okay. Now, if you had proper getter setters, so in the setters, you have your validations, right? You check whether balance is negative or not. You check whether the balance is too huge or not. You put these restrictions. So if you have marked it private, no one can just say this dot set minus 1,000, because the validations will fail and we will give an error. Correct? But if you don't put those validations hardly, right? If you don't block any changes, then someone can just come and simply say that this dot balance equals to minus 1,000, and someone's money will be gone, right? So this has real world implication now.
Yeah, that makes sense, but there is no direct way to modify the code, right? Normally, when hacking happens, it's due to some database
Hacking is a
access.
completely different thing, right? See, we are not trying to stop hacking. We are trying to stop ourselves from hurting ourselves, or someone who does not know how your code works hurting themselves, right? We are trying to prevent that. So with that, you can write all the documentation and all the good practices to follow while writing a code. Still, there are people, like, from 5 years, 2 years down the line, 3 years down the line, someone will come and make a change that will just break everything if you don't put proper guardrails around it. So with that, let's move on. Let's move on to abstraction. Yeah. Any one of you want to explain what abstraction is? Yeah, maybe someone else.
Hiding implementation detail and showing essential features.
Exactly. So abstraction basically means, I'll give you a pretty simple example. So it basically means hiding the implementation and giving the contract to whoever wants to use it, right? So let's say you implement some library that has, so yeah, let's say you have a notifier, okay? So people can use an email notifier or SMS notifier, right? Or maybe message SMS, okay, right? WhatsApp notifier, right? So maybe you have implemented all of these functionalities, right? Now, the client who wants to use your application does not need to know how exactly is email notifier implemented internally, right? It does not need to know how SMS uh, notifier is implemented internally. All it needs to know is that there is this interface or there is this contract called notifier that gives me a function send, right? And when I call this function send, whatever kind of notifier I'm using, it will send that notification. Okay. So they will create an email notifier. They don't care how it is implemented internally, and they just will simply call email dot send. That's it. And it will send, right? They don't need to know how it is working internally and everything. They just need to know this contract, this notifier contract, right? This is basically the interface. So that's abstraction, where we hide the implementation detail. We just share the contract that they can use to do things that they want to do. Okay. One other example for this will be simply the Java list that there is, right? So simply we can create like that is how it is done. So public interface list, right? There is a list that is created. Then there are functions in this, which is basically add, right? There is add, and let's say there is remove, right? Remove. So let's say there's just these two functions. Then someone can simply use, let's say, and there are two implementations of this. One is the array list, right? And this somehow implements it. Implements list, right? And then there is public interface, sorry, public class, maybe a linked list. Okay. This also implements a list. Right. Now, if someone was using an array list, right? If someone was using an array list, they can directly replace it with linked list without worrying about anything. How will their functionality change or not? This is all taken care of internally, and they just need to just swap array list with linked list, and everything will continue working. So this is the power of abstraction, where the caller or the client does not need to know how these individual components are implemented, right? We hide this detail from them because they just don't need it basically, right? Yeah. So any doubt on abstraction? Yeah, Tanisha, go ahead.
Yeah, so regarding the abstraction, sometime we know like abstraction, I will go in bit deeper. So we know abstraction can be happen via abstract class or interfaces. So
Correct.
we get the question sometime in the interview like what is the difference regarding like in the perspective of newer like newer Java or at latest because there is almost similar.
Yeah, newer Java, they are almost similar. Even I am not sure what are the differences in newer Java. I know what are the differences in older Java, that you can know interfaces cannot have partial implementation or default implementation, whereas abstract classes can have. But after Java 8, even interfaces can have their default implementation. There is one more thing, one major thing that is different, which is that you can implement multiple interfaces, but you cannot inherit multiple classes. Okay,
Yeah.
so let's say you have this list class, and then there is, let's say, some other interface. Okay, some other interface, let's call that interface B, and we want that this array list should implement both list and B. That is possible, right? But if you
Yeah.
convert both of these to abstract classes, right? If you
Mhm.
convert both of these to abstract class, right, then this is not possible.
Yeah.
Then you cannot do this. Then you cannot say public class array list extends list comma B. You cannot do this then. So interfaces let you do that, and abstract classes don't let you do that. That is, I think, one of the major differences in newer Java.
Mhm.
Okay.
Okay. Yeah.
Yeah. So with that, let's come to inheritance. Yeah. Anyone wants to tell what is inheritance?
When the child class inherits the property of its parent class, that is called
Right.
inheritance.
Yeah. So inheritance basically is used to represent a relationship between objects. Okay. For example, animal. Sorry, a dog is an animal. This is the most classic example you guys have already seen, right? So dog is an animal. So we can create a parent class. Okay, we can create a parent class animal, give it all the basic functionalities like maybe eat or sleep, right? Then with dog, we can say dog extends animal, right? So now dog will get all the functions and properties of animal, but it can also implement some of its own, right? For example, it can implement bark, right? It can implement bark, and then if you do dog dot eat, even this will work. You can say dog dot sleep, even this will work. But what you cannot do is what you cannot do is animal dot bark, right? Because animal does not extend dog. It's the other way around. So inheritance is used to represent is a relationship. Okay, clear till now? Awesome. Now this is where I would like to take a little bit of detour from 4 pillars and just give you a good practice. Okay, so the problem is that inheritance of course very powerful, but it has a few problems. Okay, and that's why we don't prefer using inheritance a lot. Okay, of course whenever it is needed it is used, but there are some cases where you will directly see that okay, this is a case for inheritance, but it does not that is not the case. Okay, and you should not use it there. So I'll give you the problems of inheritance, right? And then we'll discuss composition, which is a solution for this. We'll discuss that later after 4 pillars. But yeah, let's start with the problems of inheritance. Okay. So first of all is the fragile base class problem. What this means? This means basically, as you saw, we created a class called animal, and then we created a class called dog. Okay. So now, and let's say there are a lot of different classes that inherit animal. Okay. Now, if something changes animal, some function changes in animal, let's say the eat function, right? Let's say that changes. If that changes, it is going to affect all the subclasses that you created. And if that change is not applicable to even one of the subclasses, maybe it was applicable when we first created the inheritance, but it is now no more applicable. Then the behavior of that subclass breaks, and it is very difficult to identify why it broke in production codes, right? It is very difficult to identify that. It's only after a production, or like when a bug comes in production, you will realize, okay, this was the problem. So that's one thing, that the base class is fragile. If you change the base class, it impacts a lot of subclasses. It changes the functionality of a lot of subclasses, and some of them might not even have the user relationship true anymore, right? Then there is the false is a cases, right, where you think it is where you think that what we call that two objects are related to each other via is a relationship, like one object is a second object mathematically or some other way. In real world also you might think that that is the case, but in reality that might be completely opposite. Okay, so a classic example of this is that square is a rectangle. Is that correct? Mathematically a square is a rectangle, right? But when you try to write it in code, that's not the case. Why? Because rectangle lets you set both width and height, but square just lets you set one dimension, right? And all the other dimensions follow from that. So this we will cover later when we discuss the Liskov substitution principle. But this is one of the problems with inheritance. Okay, we'll cover this in detail later. Okay. And then also the case where that I already said that inheritance is permanent. Once you have said that some class is inheriting its properties from a different class, right? Once we have picked that hierarchy, it cannot be changed, right? And if you want that a class should inherit from multiple classes or multiple parents, that's never going to be happening, right? You cannot inherit from multiple classes in most languages. In like some languages support it. I think JavaScript supports it. I'm not sure, but Java does not support it. That's for sure. Okay.
C++
So
supports it.
yeah, C++ might support. So yeah, that's the case. So that's why we'll see how composition solves all of these problems. But yeah, we have to be very careful when we are using inheritance. Yeah, Deepak, go ahead.
I had one question, like somewhere I've read that composition is better than inheritance, and then we need to use more composition. And I really didn't understand, like, why is that? Maybe because I didn't work in that scale. So
Yeah, we'll cover that in today's class. Why we would prefer. Like, I'll give you a proper example. Okay. So I'll give you an example where inheritance just breaks completely.
sure.
Okay.
Thank you.
Yeah. So next up is polymorphism. Yeah. Anyone wants to explain what is polymorphism?
One entity
Polymorphism is multiple behavior. If a class can have a multiple behavior, in that case we use a polymorphism. It can be achieved by two ways, using an method overloading and method overriding. Or method overriding requires a easier relationship.
Right. So yeah, let me just tell what Govind is saying. I think it was not audible for everyone. So basically, polymorphism is when a single method, right? Single method name, not a single method, a single method name can do multiple things. Okay. And what decides like a single method can have multiple implementations, and what decides which of these implementation will get executed. There are some parameters that decide it, and based on those parameters, it can be divided into two things called compile time polymorphism or runtime polymorphism. Okay, so I'll give you a very classic example that everyone uses for this. Okay, I have it here. Just give me 1 second. Okay. Yeah. Yeah. So this is, sorry, where did it go? Yeah. Yeah. So this is polymorphism. So this is an abstract class that we created called shape. Okay. And then every object, every shape extends this base class. Also circle extends shape. And this shape class has a function called area. Okay. Now this circle has its own implementation of area, correct? It is the same name area, right? It has the same, it has some implementation of area. Similarly, a square has the same name area. It has some implementation of how to calculate area. And similarly for triangle. Now, this is the caller side, right? Let's say we have a list of shapes. Okay, we have a list of shapes. And then we are calling shape.area. So here we're not calling circle.area, like explicitly we're not calling circle.area, square.area. We are just simply calling shape.area, correct? But it will still execute and give like it will find out what kind of object this actually is and then execute the area function of that. Okay, and that you cannot know while compiling. Okay, let's say this code is getting compiled. So while compiling, like, okay, here it is, the list is what we call static list. So here you can tell, but let's say this list was dynamic. It was coming to, we were calculating this and this was coming via some other function or anything. Let's call that this list is dynamic. So when you're defining system.out.println s.area, right, at compile time, you don't know that which implementation of area, which implementation of these three areas will be called in actual when it is actually executing, right? So because we don't know at compile time, this is called runtime polymorphism or overriding a method. Okay. And when you're overriding, one thing that is important is that an overridden method has the same number of parameters and the return type as all the other methods that it is overriding. Okay. So how do you identify a method? एक उसका नाम हो गया, right? One is the name. Then second is उसका return type, right? Second is return type. Third is what I was saying. Third is the number of parameters and the type of parameters it is taking. Correct? This is how you will uniquely identify any method. Correct? So as you see, for this area function, all three are same. Right? The double, the return type is same. The name is same, and the number of parameters it is taking, the type of parameters it is taking, it is same. So when all these three are same, right, that's when we say that it is runtime polymorphism or overriding the method, because now there is really no way to know that what function, what we say, what implementation of this method will be called, right? Similarly, there is something called compile time polymorphism or overloading. Okay, here we know at compile time what implementation of a given function will execute. Okay, so I'll give you a pretty simple example. Let's say we have a class shape. We are not doing any of that abstraction. Okay, we are simply saying we are simply saying public double area, and then if we are taking int a, right, then we are return a into a area of a square. Okay, similarly we have public double area. This has int a and int b. Okay, here we simply return a into b. Okay, now this is an example of method overloading. Why? Because here, even though the return type and the name of the function is same, but the parameters that it accepts is different. So whenever you want to call this, how will you call it? You will call shape.area and then pass 1, correct? So because there is only one method that satisfies this signature, which is this, it knows at compile time what implementation will be called, and maybe Java can apply some optimizations here, right, internally if they want to, but that's not the area that we want to cover. And similarly, if you call shape.area 1, 2, right? If you call shape.area 1, 2, it will, there is only one signature that matches this, which is this. So at compile time, you can say that which implementation will be called. So any doubt here? Yeah, Deepak, you can ask.
Just wondering about runtime polymorphism.
Hmm?
So we are already defining what type of object we want to assign, right? So compiler can see the what type we are assigning, and then it's not really runtime, right? Because
No, compiler cannot see, right? Imagine this. Okay, imagine there is a random number generator. Okay, and basis this value, we are running. Let's say we are running a loop while I is less than 5. Okay, we are generating a random number. Okay, and basis this random number. So if, let's call this R. Okay, basis this random number, if R mod 3 equals 1, create a circle, right? Create a circle like shape proper like this. Shape, or simply do this, what we call with this shapes, right? We do shapes dot push or append, right? Shapes dot append this. Okay. And similarly, else if it is 2, then do this. Instead of circle, do square. Okay. And similarly, the third one, which is do triangle. Okay. Let's say we did this. Now, this will be randomly generated. Am I correct? Now,
yes.
Now, can you tell that compiler will know which area implementation will be there?
No, I mean, in the new code written we can't, but the current code, it's possible.
Yeah, that's what I said, right? Assume that this is a dynamic list. And even though it is static, right? Imagine writing a compiler. Compiler is at the end of the day a piece of code, right? A piece of software. Imagine writing a compiler, and then you have to also now you are trying to implement a compiler which can identify these cases where it is a very clear case of runtime polymorphism, but you are trying to write a compiler that can identify these niche cases where it can know at compile time which implementation will be called. So that's just a waste of time, right? Because anyway, this is pretty clear. This is a very clear example of a runtime based polymorphism, right?
Yeah, makes sense.
Yeah. So yeah, that's pretty much it. That's pretty much the basics of object-oriented programming, classes, objects, and stuff, right? So if you have any doubts so far, this will be a good time to ask. Now we'll move on to the solid principles and the other principles that we should use, that we should follow while writing code. So if you have any doubt, ask in the chat or raise your hand. If not, give me a thumbs up and we will move on. Awesome. So a lot of thumbs up coming my way. So, and also if you feel that the pace is too fast, the pace is too slow, if I should, maybe explain it in Hindi, in English, let me know. If there is a majority for it, I can, of course, like the goal here is that you guys should learn. So that is what I want to focus on. It's not, the goal here is not that I can come and I can just do my bit and go. Okay. So if you want some changes, let me know. So with that being said, let's start with solid principles. Yeah. So solids में सबसे पहले S आता है. Like let's start with S. What does S stands for? S stands for single responsive. Oh, sorry, we skipped the composition part, right? I did not tell you. Okay, so let's go with the composition wala. Sorry, my bad. Let's go to composition. Okay. Why I said composition is better. So here's a question to you. Okay. We are trying to design a software for a car company. Okay. And we have different kinds of car. Maybe we have car, or you can say, yeah, we have a car. We have different kinds of car. We have electric car. Okay. Like, of course, we have a normal car. Then we have electric car. Then we have, of course, gasoline car, right? So this basic car is basically a gasoline car. And then we also have a hybrid car. How would you design a system that incorporates this? Let's start with inheritance.
You define car as the main class with abstract, like make it an abstract class, and then electric car would inherit car, and hybrid
But what
also
would
would
be the
be.
functions of the abstract class car? So let's say I'm creating public class car, right?
Hmm.
I'm not creating an abstract class because let's say that class is the one that inherits the basic functionalities. So yeah, what will you have? You have, what are the functions that you will put in this car?
Drive.
Okay, yeah, drive is one. What else? The major thing that we want to just talk about is around the fueling wala cheez, okay? Yeah, we want to talk about fueling. So there's similarly there will be a fuel up function, right? Engine is not a function. Engine is part of the system, right? It's not a function. I'm talking about functions.
Start, stop.
Yeah, start, stop. That's awesome. Okay. Yeah,
Braking.
yeah, start, stop, braking. Let's say these all things are common in the types of car that we have. All this is common, right? Yeah. So we have a public class car that does all of this. I'm just going to say here like this, and I will highlight the feature that I want to focus on. Okay. Fueling. Okay. So this is the basic gasoline car. Am I correct? Right?
The only thing changing is the engine, so we can make everything else as a part of a parent class and only part of an engine as a child classes.
Yeah, but that is a composition, right? That is the composition part. We are trying to, like, I'm trying to highlight the problem of inheritance. Okay. Like the you said, right? You read somewhere that inheritance, we should avoid using inheritance. So this is an example for that. I'll highlight the problem and then we will talk about composition. Okay. So
No, I mean,
this is,
what I was saying is like, everything we can define in a parent class except for engine, and
okay.
engine can be different classes which can be inherited, like, which will inherit from the parent class, which is car.
So you are saying, sorry, this is all car, and then there will be an engine, right? Engine.
Every type of engine will be a different class, like
Yeah,
electric car,
then,
hybrid car,
yeah.
ICE.
Yeah, that is the composition, right? Because now you're composing. That's what I'm talking about. Just give me 1 second. I'll give you an example. Okay. So this
No,
is the, yeah, wait. I'll come to that. You are saying that what you are saying that is correct, and that is an example of composition. But this is, we are talking about inheriting right now. Okay. So a car has this fuel up function. Okay, a gasoline car has this fuel up function. Now let's say we want to create a electric car. Electric car should have all the features of a normal car, correct? An electric car is a car, right? So it makes sense that we create a inheritance kind of system here, right? So we create public class electric car extends car, right? So we create this class, but now electric car has no use for this function called fuel up, right? It has no, like, electric car cannot be fueled up. Electric car maybe needs something like a charge battery, right? It needs a function like charge battery. It does not need a function called fuel up. So now for this electric car, we are unnecessarily carrying a function called fuel up, right? So this is one of the violations of solid principles. We'll come to that later, but this is a violation of solid principle, that the electric car now has to worry about a function called fuel up, and anyone can call on it, and it might cause some problems. Like, we have to manually handle this. So that's a problem. Then this is the first problem that I've identified. Now, second problem is, let's say we want to create a hybrid car, right? We want to create a hybrid car. So for hybrid car, what you will say? You say public class hybrid car. Hybrid car has both gasoline and electric features, right? It can charge battery and it can fuel up as well. So for this hybrid car, we need both the functions. But if you're using inheritance, then you cannot actually do it, right? You can either extend it via car, or you can extend it via this, what we call electric car, right? Right? You can extend it via only one, and then the other one you have to duplicate, right? Whatever, if you extend it via car, then you have to duplicate the charge battery function, right? So you have to write it again, and that's again a bad practice, right? We are duplicating code, and this code, like this, these can go decoupled with each other. So that is the problem with inheritance, that as you saw here, this is one of the examples where inheritance, even though an electric car is a car, a hybrid car is a car, right? Even though that makes sense, but designing the entire thing around it will break the system. Okay, so that's why what now we'll do is we'll move this entire fueling wala part that is very specific to engine to some other classes, right? And use that class as a part of this car. Okay, that's composition. Composition is basically you dividing the functionalities into different classes and using those classes as part of the super class that you want to build. Okay, so similarly, so now let's start with what an ideal design for this problem would look like. Okay, so we will create a public interface engine, right? So we'll create an engine. So of course, like, we cannot go away with inheritance, but inheritance is still used and it will be used everywhere. But it's about how you structure these interfaces and classes so that it benefits you. Okay, so we have a public interface engine, and this will have a power function. Okay, this will have a power function. Now there will be a public interface or public class, you can say, public class gas engine. Okay, gas engine. This will implement engine, of course, right? And of course, power, it will get power from above. It will just implement fuel up, right? And if you want to modify power, it can modify power as well. That's up to it. Similarly, we'll have a public class electric engine. Okay, this will also implement engine, right? And this will implement power. It will again get from above, but it will get charge battery. It will implement charge battery function, right? And similarly, a hybrid also now can simply implement both of these functions. So let me just do that. So we have a hybrid car, okay, which implements its own charge battery and fuel up functions. So now we have an engine ready. Now we can plug this engine into any type of car and make it work. Okay, so now we can simply create public class car, right? And now this will have an engine, right? This now class has an engine. So has a relationship is defined by composition. Okay, so we'll have private private engine. Okay. And then when we initialize this car, when we say public car, okay, and this will accept an engine, right? And we'll simply do engine dot this dot engine is equals to engine. Okay, now this one class car can be used to create an electric car. It can be used to create a hybrid car. It can be used to create a what we call electric car, whatever you want. Okay, so this will also implement a drive function, which will have something like uh, engine dot power function, right? So now it does not need to care how this engine is implemented, right? So this car now has an engine. So if you want to create an electric car, it's pretty simple. You first create an electric engine. How do you do that? You just simply say engine. I see. Okay, whatever. I don't did not get it, but okay. New electric engine. You just simply say new electric engine, and then you say car C1 is equals to new car with E, right? You can call it electrical engine. You can just pass electrical engine. Similarly, you can create all different types of engine, right? You can create hybrid engine, and simply all you need to do is car C2 is equals to new car HE. So now this car C2 is of type hybrid, whereas this car C1 is of type electric, right? That's where this is the power of composition. When you try to break down the systems into like electric car is a car, but if you just break it down like car has an engine and engine has these different types, when you break it down like this, that's when the system, the beauty of this system comes out. That's when the system becomes extensible. Let's say tomorrow a new type of engine comes in, you don't need to change anything. All you need to do is you need to just implement this engine here. Let's say public class new modern engine, right? You create this. This also will implement any general engine, and then you can use it in your car simply, right? So this is what I wanted to say when I was saying that composition is very powerful. Okay, if someone is facing lag, then it might be because because of your network condition, or I don't know, because of mine. But the class will be recorded. You can maybe go back and have a look then. Okay, so with that said, any doubts so far in composition, inheritance, anything? If no doubts, we'll move on. Okay, awesome. So now let's start with solid principles. I think we are good to go. Yeah. So with today we are running a little short on time, so we might not be able to cover the tic-tac-toe design. If that's the case, we'll cover it in the next class. Okay. UML, LLD framework, and tic-tac-toe we'll cover in next class. Okay. Today we'll maybe just focus on solid principles and some other principles. Okay. So with that, solid stands for single
Single
responsibility. Correct. Single responsibility principle. What this means? This means that a single class should have only one reason to change, or a single class should handle only one responsibility. A class or a method should not handle multiple things. Okay. Like, for example, I'll give you an example of a bad code. Okay. I have it written over here. So let's say this is our class. Okay. This is our class user service. Okay. It has this function public void register. Now, when you are trying to register a user, what are the things that you do? You hash the password, you save the user information to DB, maybe then you send a welcome email, and then you just log some analytical event saying, okay, that a new user joined. So this flow makes sense, right? That when a new user is registered, this is what we do. But I have a question to you guys. Maybe you can raise your hand or put in the chat. How many reasons are there for this one function to change? Like, when is the possibility that this function might need to change?
Welcome
Only when
email
a user
templates,
comes.
Sanchez.
Sorry, please raise your hand and then I'll let you go one by one. 4 is fine, but I want the reasons.
Whenever a user is registered, only then it should change. But in this case, anytime there's a change in password or any email is coming or analytics is there, it'll keep changing.
No. I don't think you understand. So this is a piece of code, right?
Mm.
Password change, like whenever this will change whenever maybe there's a change in the hashing technique for password, right? Maybe
Mm.
earlier using bcrypt and now we have moved on to some new kind of hashing, right? So whenever you need to change that kind of stuff, then this changes. Any other example?
When we change the database or how the welcome email we are sending, and when we change any analytics of the events.
Exactly, right? Let's say when you want to change the database, we are using SQL database. Now you want to go to NoSQL database. Now a database change is now requiring you to change this register function, correct? Similarly, email, right? Let's say someone was like you were sending some different kind of mail earlier. Now you have to send some different kind of mail. Even then, this register function needs to change, right? So all of this is bad, right? You don't know, like if this function changed for so many things, it's very difficult to scale it, right? Even like manage it, scale to do that. It's very difficult to manage it, right? It's very difficult to know when this should change, know when this should not change, and know that when the change that you are making, it will not affect anything downstream. All those decisions are very difficult to take. So for this, what we can do is we can divide each of this responsibility into separate things, okay, separate services, and then we just then we just ask those services to perform their action, okay. So for example, if you want to split this task, okay, I have written it. Just give me 1 second. Yeah, yeah. So this is the updated one. Let's go. Yeah. Okay. So now imagine about this. Okay, we have a public class password hasher. This will hash the password for us. Okay. Now, if you want to change some hashing technique or anything, this is the function we change. This is where we make that update. Then there is this user repository function. This class has this class has the responsibility to commit that changes into a database, to communicate to the database, make the changes there and commit it. And this email service is responsible to send the email, right? You just give it the user ID and it will send the email to that user. Similarly, there is analytics service that you can use to log. Now, in our initial user service, we use all of these. Okay, we like this user service needs this password hasher. This user service like has a password hasher. This user service has a user repository. It has all of these classes, and when you want to register a user, we just ask these classes to perform their respective actions in a sequence. So we ask the password to be hashed, we ask the repository to save the user, then we ask the emailer to send the email, and then simply uh, track it via log event, right? So now if any one of these things change, you just need to change in one of these functions. And if this flow changes, like if you want to maybe send instead of like if you want to send analytics track before an email, right? If you want to do this before an email, then only then this register function changes, right? This only changes when there is a flow in the change in the process registration flow, right? That's the case when this changes. So that is protecting the single responsibility principle, which is basically that any class or any method should only change, should have only one reason for changing, okay? Or it should have only single responsibility. All right. Any doubts in single responsibility principle? Okay. So now let's talk about the second one, which is O. O stands for open for extension, closed for modification. What this means basically exactly what it spells out. It means that when you are trying to add new functionality to your code, right? When you are trying to add new functionality to your code, it should be the case that you should not change any of the existing things that any of the existing code that is there. You can add new code, you can extend the functionalities, but you should not change any of the existing implementation of anything. Okay. So I'll give you an example similar to what we already did, right? Let's say we are implementing an area calculator class. Okay, we have this class, public class area calculator. It has this calculate function. It takes in the shape object and it just checks whether if shape is an instance of circle, then do this formula. If shape is an instance of square, do this formula. If shape is the instance of triangle, do this formula. Now let's say tomorrow the ask is that we want to find the area of a pentagon. Okay, we want to support pentagons in our system. So how will you do it? With this code, how will you do it? You will modify this existing function calculate, right? You will come here to this calculate function. You will change it, right? You will modify this to say else if shape is shape instance of what we call, sorry. Yeah, if shape instance of pentagon, then calculate pentagon ka area, right? Then calculate pentagon area. So this is modification of existing code, correct? This is modification of existing code. This is a bad thing to do. So how do you solve this problem? You solve this problem via something that you have already seen, polymorphism, right? You create a common class shape and you give it an area function, and then every class can just implement that area function. And if a new pentagon kind of shape is coming up, so then we will just get a new class pentagon that will again extend shape and it will implement its own area, right? Clear? Open for modification, open for extension and close for modification. Any doubts? Awesome. A few more thumbs up I'll need before moving on. If you have any doubts, feel free to ask. Okay. Yeah. Awesome. Awesome. So now the most confusing one, the L. L stands for risk of substitution principle. Okay. This means that any subclass that you create, it should be easily replaceable with the parent class, right? Let's say you are using a parent class somewhere, then all the subclasses that you create, right, they should simply fit in there, right? You should it should not be the case that you were referring a parent class somewhere, and when you try to switch it with a child class, your behavior breaks. Okay, so simply put, it means that subtypes must be substitutable for their base types. Okay, I'll give you an example for this. Okay, this is the rectangle and square example that I gave, right? So I'll just take the code. Give me 1 second. And this is again an example where inheritance breaks. Okay, so we have a class rectangle. Okay, it has a width and a height. We say public set width. This will just do this dot width is equals to W. Yeah, it is kind of similar to dependency injection. Yes, we'll come to that later. Okay, so yeah, so when you say set width, this simply says this dot width is equals to W. When we say set height, this simply does this dot height is equals to H, and then area it calculates with width into height. Correct? Now mathematically, as we already saw, a square is a rectangle. Correct? So using inheritance here should be fine mathematically. So if we try to write a class, public class square extends rectangle, right? We can write this class. This is extending like this, and then we have the set width function which we have overridden. So set width, what it does, it sets both the width and the height, right? Similarly, the set height function, it sets both the width and height to the given function, because for a square, the width and height should always be the same, right? So basically, this is like overriding, this is basically overriding the set width and set height function to actually modify both of those. Now let's say that you have written a test somewhere in your system. Okay, I'll show the test also. let's say you've written this test where we say that public void test rectangle, we are trying to test rectangle. We say r dot set width 5 and r dot set height 4. Assert that r dot area should be 20. Right? Now, if we try to substitute square here, if I simply say square, so will this test still hold?
No.
No, right? This test will not hold. So this is a violation of what we call this Liskov substitution principle. Okay. This is a classic example of Liskov substitution principle. And this is something, this is how do I explain? This is something that you will not actively see. This is not something that you can actively learn how to implement. But the more the number of systems you design, you will automatically develop an eye that you will start to identify, okay, that this will violate the Liskov substitution principle. Something like as we go design more systems towards the end, you will start seeing this in the designs automatically. So don't fret over it too much. It basically means that all the subclasses, they should not change the behavior of all the parent classes that define some behavior. These subclasses should not, this should be easily substitutable to that. Okay. That's what it says basically. So that being said, yeah. So now the next is I. I is interface segregation principle. Okay. Now, if you remember in the car example, I said that now that when we are trying to extend electric car from a normal car, the car should now, also know about fuel up function, right? It should know about fuel up function. So this is where this principle is violated. This principle simply says that all the clients that are there, they should not be forced to depend on interfaces that they don't use. Okay, so I'll write it down and then I'll explain with an example. Okay, clients should not be forced to depend on interfaces that they don't use. Okay, let's try to understand this with an example, and it will be very intuitive. Like it's super intuitive. So let's say I have this interface, public interface multifunction printer. Okay, so this is an interface. Now this multifunction printer can print, it can scan, and it can fax also, right? It can do all of this. Now, if I'm trying to implement a simple printer, trying to create a simple printer by implementing this multifunction printer. This simple printer only knows how to print, right? It only needs to know how to print. It does not need to know how to scan. It does not need to know how to fax, right? But it has to implement these functions because this multifunction printer interface, this defines these functions. Correct? Thumbs up in the chat, right? This is the problem, right? Why should this simple printer know that it has to implement scan and it has to implement fax when it's pointless for it? So the fix for this is basically saying that this interface, multifunction printer, this interface is too fat. Okay, this contains a lot of functions that all of the dependencies don't need. So a better fix for this is to just separate this interface into multiple interfaces. Interface segregation, right? Interface segregation. We want to separate this interface into multiple interfaces. So we will create multiple interfaces. This is the fixed code. Okay. So this is the fixed code. So we have public interface printer. This the printing part. We have public interface scanner. This just the scanning part, and we have public interface fax machine, which does the scanning part, right? So now creating two different kind of printers becomes so simple, right? See, we have public class simple printer. This implements printer, only the printer, right? And it also just implements the print function. It does not even care about scan or fax or anything, right? Similarly, there is a multifunction printer, let's call it. Multifunction, let's just call it multifunction. So we have this multifunction printer. It implements all the printer, scanner, and fax machine interfaces. So now, because it needed all of them, So it can implement all of them, and because it knows how to print, it knows how to scan, so it can implement those functions to achieve the functionality. So is this clear? Awesome. Awesome. So now the last one, which is the dependency injection principle. Okay, dependency injection principle. This is a D. Now, what this principle says is, that you should depend on abstractions, okay, and not concrete implementation of stuff. So, again, I'll give you an example. So it says depends on abstractions and not implementations. Now, this is a principle that we have already used so much in this class that at this point, you would already be thinking in this manner. I'll give you an example. Okay. So let's say we are implementing a order service or some service, right? Let's say we are doing public class order service. Okay. You will automatically start to see problems now. So we have private email notifier, okay. And then we shall simply say public void place order, okay. So it will maybe have an order, and we will simply say that we'll simply do the order wala part, and then we'll simply say that we need to send email notifier dot send. Now, do you guys see any problem with this code? I want you guys to tell me, do you see any problems? If there are any problems, then what are the problems? Yeah, Deepak, go ahead.
Email notifier is not defined, like we only declared it.
No, assume it is declared. Assume there is like a constructor that is initializing it.
It is tightly coupled.
Explain a little bit more.
So basically, what happened in this piece of code, suppose if I just want to create order service, then inside that we need to create the object by our own self of another class, right? And therefore, it is tightly coupled, and it is not advised to write the code in a tightly. Therefore, we are following loosely coupled. So, for example, in Java, Spring or Spring Boot solve this problem.
No, that is. So you're confusing it with dependency injection that is done by Spring Boot and Java. That is not this. Think a little bit more. This is not the case. So tight coupling is the right reason, but there are other more problematic reasons. And tight coupling is like there's a different meaning of tight coupling here than what you are saying. If someone raised hands, I cannot see. Just a minute. Yeah, Deepak Patel has raised and who has raised? Madhuri, you can go.
Yeah, maybe I do not want to send the notification through email in this case. I want the notification to be sent by a different form.
Exactly. Let's say we want to send the email, we want to send a notification via SMS or push. Then what is the way to do it? The only way to do it is having more dependencies in this, right? You have to do something like this, right? Right? And then maybe here you take some kind of a preference, or you do this. You do something like this. If email notifier, then send email notification. And if SMS notifier, then send SMS notifier. Right? This is something that you have to do. Correct? If you want to use a SMS notification or some other kind of notification, this is what you need to do. So that is one problem that you identify, that we can't swap easily. right? And if you want to add different kind of notifications, then we have to depend on more concrete implementations. Yeah, Deepak, you can go next.
The only place I've used dependency injection is where we are doing unit testing, where we want to have a stub instead of a actual database.
Exactly. That is the other use case, which is we cannot test this, right? Now, if you want to test the auto service, you need a concrete implementation of email notifier, right? Right? Otherwise, this will just not work. Correct? So we have to either we have to create an email service from, like, you have to create a new object, proper object for email service, or we have to mock the entire email service object, right? And then again, same problem. The early problem is there that we cannot just simply add more kind of notification or swap the notification type easily. Now then there is tight coupling as well, right? If you change the email notifier right now, like today, email notifier sends the notification via .send function, correct? Tomorrow it will send the notification via, let's say, .send email function. So that change in function now should also reflect here, right? Now you should come here and say that email notifier should send an email, right? Correct? Am I correct? So these are the problems. This is the tight coupling that I was referring to, that any change in email notifier, it may propagate into order service for no reason at all, right? So the fix for this is that you don't depend on concrete implementations. You rather depend on abstractions. What do you mean by that? It's pretty simple. I'll give you the fixed code example as well, and then we'll see. Okay. So we have here fixed code. Yeah. Yeah. So if you see at this fixed code, first of all, we created an interface notifier, right? And all the different kind of notifiers, the email notifier, the SMS notifier, the push notifier, they implement this notifier and they implement a send function, right? They implement a send function, and then we create an order service. And this order service now depends on the notifier interface rather than the individual classes, right? Now tomorrow, if you want to send a notification via SMS, when you are trying to create this object, you just pass a SMS notifier and it will just it will send it by notifier.send, right? So that's the first problem solved. That now you can swap easily, correct? Now you can swap very easily. You don't need to worry about it. Now comes the second problem, which was testing, right? Now when you're trying to mock, you can just mock this interface, right? You can just mock this interface and you don't need to worry about how email notifier is implemented internally or anything. You don't need to worry about anything. You just need to mock this one interface and you are done. Correct? Correct?
My question is using overriding from an actual class, like when you're inheriting, is also possible, right? Like, why is there a very strong need to make it an interface and then inherit and all that?
Sorry, I did not get
So see,
what overriding?
notifier in notifier you've basically created an interface of notifier, right?
Right, right.
So the whole point of a notifier is that you don't really define the function, like there's no return and all of that. It's just empty, and then
Right.
you just extend that implement that and you keep inheriting it. So instead of that,
This is not
when
inheritance. This is an implementation. Please understand that this is an interface. An interface by design don't have any implementation. The interface is a contract that any class that is trying to implement in this interface should have these methods defined inside of it.
okay.
So this is
Uh,
not inheritance.
Uh, yeah, I mean, like I'm just telling in terms of Python. So in Python, there's no like stark difference between inheritance and implementation.
Right.
It's the same
Python
thing.
does not have interfaces at all. Like you
We
have
have
to,
abstract class basically. That's
yeah, you
the
have abstract classes, right?
so my that's what was my question. Like, just forgive the technicalities, but
Mhm.
what I'm saying is, instead, can't we just use a like base class like notifier and then inherit notifier, uh, and override the send?
Yeah, that is the pretty much the same thing, right? If you create abstract class notifier, right?
Hmm.
That is acting as an interface again, right? So
Yeah,
it can
but
have a default implementation. That's it. Now then that it becomes inheritance.
like, why is there a push to use interfaces or?
Yeah,
Uh,
because see, this is all these principles, right? They are created around Java because Java like was the language when all of this theory was being like all of these good principles were coming up. Java was the
mm,
most famous language. So that's why these all good principles they are built around Java. But
mm,
don't take them for the face value. Try to understand what is the problem that they're trying to solve and what is the principle that they're trying to imply. Just try to follow that, right? As you
mm,
said, technicalities don't matter like if
okay.
you're switching languages, technicalities don't matter. What matters is that you understand the concept that if we try to depend on these what we call concrete classes, right, then making changes becomes difficult, right? Testing them becomes difficult. So
Mm,
try to depend on abstractions. Now, what you said is an example of abstraction only, right? When you create an abstract class and then
mm,
implement it, so that's
mm.
fine, then you're still following the principle.
But like what I'm saying is like when you're designing, let's say some
Hmm?
system, how would I know that I'm not over engineering and or if I'm not using the right principles?
Experience. And that's
Okay,
only answer that is experience.
okay, yeah, thank you.
Yeah. So I think we are at time today. So if you have any questions, feel free to ask. Okay, sorry, a few more principles that I wanted to talk about. These are not very detailed principles. These are just kind of like good acronyms that people created. So there is one is dry. Does anyone of you know what dry means?
Do
Do
not
not
repeat
repeat.
yourself.
Exactly. Don't repeat yourself, right? It's pretty simple that when you're trying to write a code, don't copy paste your code into multiple places. If you feel that there is a need that you need to use the same piece of code at multiple places, just create a utility function and use that, or just create a common class and use that, right? That's the crux of it. Dry means don't repeat yourself. So follow this as much as you can, right? Then there is kiss. Do you know what this is?
Keep it simple and short.
Keep it simple, stupid. Yeah. So this is like cool tech bros writing acronyms. This basically means that when you are trying to design a system, don't over-engineer it. Okay. Uh, don't try to fit in all the like we'll learn design patterns, right? So don't try to fit in all the design patterns into it. Focus on the problem. Keep the solution simpler. Sometimes the most beautiful solution is the most simpler one, right? So keep an eye out for simple solutions. Okay. So this basically just means that. Okay. Then there is Yagni. Do you know what this means?
You're not gonna need it.
Yes, you are not gonna need it. This is pretty simple. This basically means that don't build for hypothetical futures, right? Don't build for requirements like what if we need to support like 50 currencies later. Like you're trying, let's say you're trying to make a payment system. Don't build your systems around what if we have to support 50 currencies later. Build your system around what if we want to introduce new currencies, then that should be easy. That's it. That's what your thought process should be. And don't make like premature abstractions. Okay. Like sometimes we create so many interfaces, we create so many abstract classes that it becomes a lot of effort just to maintain that. So sometimes a lot of abstraction is worse than no abstraction. So striking that kind of balance in between making our system ready for future all the future possibilities versus making a system that works now and has some extensibility, and then maybe if as and when needs right, modifying it. Okay. So these are basically the principles that we'll try to follow throughout the class, throughout all the systems that we'll design. Okay. So this is pretty much it. I know today we planned a lot of things, but we could not cover it. But I think today was a very fruitful discussion. I really liked it. So if you have any doubts, go ahead. Otherwise, you can close the class 5 minutes early. It's all right. Yeah, Deepak, go ahead.
Just wanted like feedback on me, like kind of questions I asked, and like is it something that we're going to discuss, or did I ask too much questions, or did
No,
I
I think
talk
it's
too
fine.
much in class?
No. I think as long as you can keep the questions around the stuff that we are discussing in class, it's totally fine. Again, the kind of languages that you use and all those things might differ. You can ask in the class, and if you don't get a concrete answer, try to be self-reliant and try to find answers outside the class, because the main thing is being curious, right? The goal here is not me teaching you everything. The goal here is you learning everything. Okay, so keep your areas open. You keep asking other people, asking chat gpt, asking all the AI thing and everything. Keep searching the internet. That's the goal, right? So it's okay.
Yeah, the goal is to learn how to learn.
Exactly. And that's what the way of my classes will be. My classes will not be like me coming and just designing a system and going, okay, done. My classes will be more like me asking you questions and me asking you to defend it as well. Okay, defending your decisions. Yeah, Tanisha, go ahead.
Yeah, I feel the class was good, like it was interactive as well. And I have one small request, like
Yep.
after the class, if we can get some hands-on exercise practice or something like that, then it will keep, like keep us moving.
Yep.
Otherwise,
Yeah,
yeah.
sure. I'll give you some questions. I have the notes ready. I'll add a question to that and I'll send that to you maybe by tomorrow
Oh,
or something like that. Okay.
okay. Yeah. Thank you.
Anyone else? Okay. So if there are no more questions, we can end the class. Thanks, guys. Really enjoyed it. Thanks a lot. I'll share this Excalidraw link with you guys as well. Okay. In the notes, I'll share this. Feel free to access it. Go through it as a part of notes. Cool. Thank you, guys. I'm ending the class.
Thank you.
Thank you.
Thank you. Thank you.